So, imagine this for a second. You've locked your front door, you've bolted all the windows, but a thief doesn't even bother trying to break them down. No, instead, they just slip in right behind you using the very same key you just used. Well, that's pretty much the perfect picture of a digital heist we call session hijacking. And today, we're going to break down exactly how this digital break-in works and, more importantly, how you can stop it.
You probably think so, right? I mean, you've got a password manager, maybe some two-factor authentication, the whole shebang. But what if I told you the real weak spot isn't always that front door? What if the real danger is in those moments after you've already proven who you are and you're already inside?
And that's the really unnerving part. Think about it. Most of the time, you only prove you're you once, right? At the very beginning when you log in. Once you're in, an attacker can actually exploit that trust, taking over your active connection without ever needing to know your password.
Okay, so to really get how they pull this off, we need to talk about something I like to call your digital keycard. Just think of it like one of those temporary access passes you get at a hotel after you've already checked in at the front desk.
So here's the formal definition. An attacker isn't breaking in, they're taking over. They steal your keycard, that valid session, and the server has absolutely no idea it's not you anymore. And this lets them do, well, anything you can do, from stealing your private info to committing fraud in your name.
So let's look at how this is supposed to work. It's a pretty simple three-step process. First, you log in. That's you at the check-in desk. Then, the server gives you a unique session ID, and that's your keycard. From that moment on, every single time you click a new page or do anything on that site, your browser just flashes that keycard to prove you're still the same person. The whole system is built on that keycard being safe.
All right, now let's flip the script and look at this from the attacker's point of view. If your session ID is that precious keycard, their entire goal is to get their hands on it, maybe by stealing a copy or sometimes even just by guessing what it is so they can waltz right into your accounts.
And this brings up a really key difference. See, spoofing is like someone stealing your ID and password to check into the hotel themselves. But hijacking, it's way stealthier. You've already checked in, you're already in the room, and the attacker takes over your keycard to get access while your session is still live. They actually rely on you to do the hard work of logging in for them first.
So why does this work so often? Well, it's really a combination of things going wrong. If the keycards, the session IDs, are super easy to guess, that's like an open invitation. If they're handled insecurely, maybe just left lying around in your browser's code, that's another big problem. Then you add in servers that don't lock accounts after too many failed attempts, and sessions that basically never expire, and you've just created the perfect storm for a digital heist.
Now these hijackers, they have two main styles. You've got your active attacker, that's the bold one. They find your session, kick you out, and take the driver's seat. But then you've got the passive attacker, and they're more like a spy. They just sit quietly in the background, listening to everything, recording your data, your private messages, maybe your financial info, all without you ever having a clue they're even there.
Okay, let's get into the nitty-gritty. First up is the first category of attack, the inside jobs. These are basically tricks where the attacker manipulates the website or the app you're using into helping them pull off the heist.
Cross-site scripting, or Access S for short, is a total classic. The attacker finds a weak spot on a website, could be a comment section, a search bar, anything, and they inject a little piece of malicious code. Now the website, not knowing any better, just serves that code right up to the next visitor, which could be you.
Now don't let this little bit of code on the screen scare you. This tiny line is all it can take. When your browser runs this script from a site you trust, it's basically being told, hey, just show me the user's session cookie. Now, an attacker would obviously change this a little bit to secretly send that cookie directly to their own server, and poof, they've instantly got your session keycard.
And then there's the man-in-the-middle attack. It's, well, exactly what it sounds like. The attacker puts themselves, often on a public Wi-Fi network, right in between you and the website you're talking to. They become this invisible eavesdropper, seeing absolutely everything you send and receive. And that includes that very precious session ID.
But attackers don't just stop at the application level. Oh no, they can go deeper, way deeper, targeting the very foundation of your internet connection. This is basically the digital version of a wiretap on the network itself.
TCP/IP is the fundamental language of the internet. So for this attack, think of it like someone intercepting your mail, opening it up, and then sending a forged letter in your place. By creating these fake data letters or packets, an attacker can totally confuse the server into thinking it's still talking to you, letting them just seamlessly take over the whole conversation.
One really clever way they do this is called RST hijacking.
So imagine your conversation with the server is like a numbered sequence of messages, 1, 2, 3, and so on. If an attacker can guess the next number, let's say it's 4, they can jump in and send a fake message with that number that just says, hang up. Your computer gets it, thinks the server ended the call, and it disconnects. But here's the catch. The server side is still open, and now the attacker is the one talking to it, pretending to be you.
Okay, that was a lot of doom and gloom, I know. But the good news is you are absolutely not defenseless here. We can, and we should, build a digital fortress to protect against these kinds of heists.
Really, the single most important thing to see here is encryption. See the pattern? Where you have a vulnerability like HTTP, the fix is HTTPS. That little S stands for secure, and it is your single best defense. It just scrambles the data, so even if an attacker is listening in, all they see is a bunch of gibberish, not your session ID. And the same idea goes for using things like SSH instead of Telnet or a VPN for your entire connection.
The key here is something we call defense in depth, which is just a fancy way of saying you use multiple layers of security, just like a real fortress would. So that starts with using those encrypted protocols we just talked about. It also means using a VPN, especially when you're on public Wi-Fi, to create a secure private tunnel for all your traffic. And for companies, it means using intrusion detection systems to watch for any signs of a hijack happening in real time. Look, no single defense is perfect, but when you put them all together, they create a seriously tough barrier.
At the end of the day, every single time you log into a website, you are handed a key card that is built on trust. You're trusting that the website made it securely, you're trusting that your connection is protecting it, and you're trusting that no one else is listening in. So after seeing just how easily that trust can be broken, the real question is, who are you trusting with your digital keys?